In this video, we will look at electricity and how it works. Electricity is the most versatile energy source we have. It is also one of the newest. Homes and businesses have been using it for not much more than 100 years. Electricity can build up in one place or can flow from one place to another. When electricity gathers in one place, it is known as static electricity. The word static means something that does not move. Electricity that moves from one place to another is called electrical current. Atoms are the smallest piece of an element containing all of the properties of that element. In order to understand electricity, we need to know the parts of the atom. In the center of the atom, you will find the nucleus, which contains the protons, the positively charged atomic particles. The atomic number is equal to the number of protons in the nucleus of an atom and identifies the element. You can see here there are 4 protons in this example. From the periodic table, the element with atomic number 4 is beryllium. Therefore, this model represents beryllium. Also inside the nucleus are the neutrons, the uncharged atomic particles. Additionally, an atom contains electrons, negatively charged particles. An atom is considered charged when there are more electrons than protons. This is a neutral atom because there are the same number of electrons, 4, as there are protons. The electrons form the outer portion of the atom orbiting the nucleus. The outermost ring of electrons is called the valence shell, and it will be the focus of our study of electrical current. The movement of positive and negative charges produces static electricity. The movement of electrons from atom to atom produces electrical current, also known as electricity. First, let's talk static electricity. Static electricity often happens when you rub things together. Have you ever walked across a rug or carpet and felt a slight tingling sensation, then touched something metal like a doorknob or a faucet and felt a sharp pain in your hand or even seen a spark? That's an example of an electrical charge. When you walk across the carpet, your feet are rubbing against it. Your body gradually builds up an electric charge, which is the tingling you can sense. When you touch metal, the charge runs instantly to earth, and that's the shock you feel. Electricity is caused by electrons, the tiny particles that orbit around the edges of atoms. Each electron has a small negative charge. An atom normally has an equal number of electrons and protons, positively charged particles. So atoms have no overall electrical charge. Suppose you rub a balloon on your sweater over and over again. As you move the balloon back and forth, you give it energy. The energy from your hand makes the balloon move. As it rubs against the wool in your sweater, some of the electrons in the rubber molecules of the balloon are knocked free and gather on your body. This leaves the balloon with slightly too few electrons. Since electrons are negatively charged, having too few electrons makes the balloon slightly positively charged. Your sweater, meanwhile, gains these extra electrons and becomes negatively charged. Opposite charges attract, so your sweater sticks to the balloon. Now that you know some of the basics of static electricity, take some time to play around with these simulations in the soft chalk lesson to learn more about how the charges react to each other.